Continuing with the EDEXCEL S2 paper from June 14R, we're on question 5 now. Now we're told the rate is 1 every 8 metres, so in 40 metres we would expect to find 5 defects. So our null hypothesis is that lambda is 5. The alternative hypothesis, which we're testing, is to see that lambda is not 5. We're asked to see if there's any change in the rate of defects. We're going to use a 10% significance level. It's a two-tailed test because we're looking at lambda being not equal to 5. X is the number of defects. So X has a Poisson distribution with parameter 5. So let's look at the tables and we can see we're looking for a number to be smaller than 5% at the bottom end, and the largest number where we get smaller than 5% is 1, and then at the top end we're looking for 1 minus 0.05, that's 0.95, looking for a number bigger than that, so 9 gives a probability of 0.9682, which means the probability that x is greater than or equal to 10 is 1 minus that, which is 0.0318. So the critical region, the numbers that would make us think there's evidence to support the null hypothesis, is x is smaller than 1 or x is greater than 10, smaller than or equal to 1 or greater than or equal to 10. The significance level is 0.0404 plus 0.0318. That's these two numbers here. Add those together, and it's 0.0722. Continuing with question 5, this time we're on part C. We've got 200 metres of wallpaper, so that's 8 times 25 is 200. So our null hypothesis is that lambda equals 25, and we're looking to see if Thomas's claim, which is that it reduces the rate of defects, we're looking to see if that's true. So we're looking at a one-tailed test at 5% significance level. So if y is the number of defects, then y has a Poisson distribution of 25. Now we can't look this up on tables, so we need to do an approximation. So y is approximately equal to, let's call this w, where w has a normal distribution of 25, the parameters are 25 and 25. So what we're looking for is to find 19 defects. We found 19 defects. So in our normal distribution, there's 25. If 19 is slightly to the left here, we want to include 19, so this number here has to be 19.5. So we're looking for this area here. By symmetry, that's the same as this area over here, where this number is 30.5. So we want the probability that w is less than or equal to 19.5, which is 1 minus the probability that w is less than 30.5. So now we can go into the z variables. 30.5 minus 25 divided by the standard deviation, that works out to be 1.1. Look that up in tables, and we get 1 minus 0.8643, which is 0.1357. 0.1357 is 5%, so therefore there's no evidence to support Sami's claim. Okay, now we're looking at question 6, and in part A we know that capital F of m is 0.5. So let's substitute that into the formula. So we get m squared over 2 minus m to the power of 4 over 16 equals half. Multiply through everything by 16, so 8m squared minus m fourthed equals 8. So m fourth minus 8m squared plus 8 is 0. It's quadratic in m squared. So m squared is minus b plus or minus the square root of b squared minus 4ac all over 2a. That works out to be 6.828 or 1.172. Now, we know that in this case we're using this formula here, so, and that only works if d is between 0 and 2. So that 6.828 is too high, so the median must be 1.172. So in question 6, part B, we know that at the mode, f dashed of d is 0. That is the highest point, the gradient at the highest point is 0. Now we know that f of d is d squared over 2 minus d fourth over 16. So f of d, that's meant to be a therefore, there it is, f of d, differentiate, we get d minus d cubed over 4. So f dash d is 1 minus 3d squared over 4. If f dash of d equals 0, then 1 minus 3d squared over 4 equals 0. Therefore 3d squared over 4 equals 1. Therefore d squared is 4 over 3. Therefore d is 2 over root 3, which is 1.1547. However, it does ask us to justify the answer. Is this a maximum or a minimum? All we found out is that it's a turning point. So we need to do a further differentiation, f double dash d, which is minus 6d over 4. If d is 1.1547, f double dash d is negative because there's a minus sign there. So therefore this is a maximum. So therefore the mode is 1.15 to 3 sig figs. And finally in part C, or on 6 part C, we know that f of 1, if we put 1 into the formula, it's a half minus a 16th, which is 7/16. So that's what we'd expect for one child, but we've got 80 children, so for 80 children we just do 80 multiplied by 7/16, which I think is 35, that's right. Just in case that's not entirely clear, I put 1 in there because we were looking for the number of children whose estimate is less than 1, so we get the probability that it's less than 1, that's for one child. For 80 children, just times it by 80. And finally, question 7, which is worth 14 marks. So the distribution asks us to write it down, so there's no working out to do. It's a uniform distribution from 0 to 9. In part B, the probability that x is more than 6, well, here's our distribution, 0 to 9. So more than 6, that has to be 6/9, or 2/3. 1 mark for this, so no working. The answer is what we're looking for. Now in part C, we get a rectangle. That's A, that's P, that's B. That length here is x. This length here must be 9 minus x, because the whole string has got length 9. So the area equals x times 9 minus x. So in other words, R, because they tell you that R is the area, that's 9x minus x squared, or if you want it in the form that they've got it, that's minus x squared plus 9x. In other words, A equals -1 and B equals 9. So now we're on to part D, 6 marks. And in part D, we need to find the expected value of R. Well, what is R? It's 9x minus x squared. So we can multiply out the brackets because this works the expected values. And that 9 can come out. So we've got two things to find out, the expected value of x and the expected value of x squared. Well, the expected value of x is easy. It's a uniform distribution, so that's just the median, which is 4.5. The expected value of x squared is a bit harder. Let's think about the variance of x. The formula for the variance of x is the expected value of x squared minus the expected value of x all squared. But there is a formula for the variance of x in a uniform distribution. It's b minus a squared over 12. So that works out to be 81 over 12, which is 27 over 4. So let's call this 1, let's call this 2. Let's put equation 2 into equation 1. So 27 over 4 equals the expected value of x squared minus the expected value of x all squared. But in equation 0, we know that the expected value of x is 4.5. So therefore, 27 over 4 is the expected value of x squared minus 4.5 squared. So the expected value of x squared is 27 over 4 plus 4.5 squared. That works out to be 27 exactly. So what are we trying to do? We're trying to find the expected value of r. It's 9 times the expected value of x. We know that. That's 4.5. That's just the median. It's a uniform distribution, so that's just 4.5. Then all this working out down here has been to get the expected value of x squared, which we've got to be 27. So let's write this information out on the next screen. So we have the expected value of r is 9ex minus ex squared. That's one of the ones we had. We had the expected value of x squared was 27, and the expected value of x, the easy bit, that was 4.5. So therefore the expected value of r is 9 times the expected value of x minus the expected value of x squared. 9 times 4.5 is 40.5. 40.5 minus 27 is 13.5. Now for part E, it says find the probability that r is more than twice the area of a square whose side is the length of the piece of string AP. So the area of the square is obviously x squared. We want the probability that r is greater than 2x squared. We want to find the probability that r is more than twice the area of the square. So there we go. So that's r. What did we say r was? R is 9x minus x squared. What's the probability that 9x minus x squared is greater than 2x squared? In other words, what's the probability that 9x is greater than 3x squared? X is not 0, so what's the probability that 9 is greater than 3x? Divide by 3, just turn it around a bit. What's the probability that x is less than 3? Well, the probability that x is less than 3, uniform distribution, from 0 to 9, it's got to be a third. And that concludes the paper.